Hey everybody, Dr. Green here. Today we're going to look at an overview of test-driven development. The key concepts for test-driven development are as follows: red, green, refactor. Test code is real code, the strategy pattern, and mock objects. So I want you all to understand this. I want you to get through this. Test-driven development is a unique development style. It's seen a lot of success. It's also hard to achieve. So the fundamental thing that we do in test-driven development is called red-green refactor, or some may refer to this as red-green clean. The interesting thing about test-driven development is you never write functional code first. You always write the test first. This is why it is called test-driven development. So you'll see from this graphic, we always start with red. We write a test for the current requirement, whatever that is. That should be a focus test that is simple and straightforward. Okay? Next, we write the simplest code possible to get the test to pass. And when I say the simplest code possible, I mean the absolute simplest code possible. When you are doing test-driven development, if there's not a test, you do not write the code. So you write the simplest code possible. You then refactor. As you add tests, you update your code, you deduplicate, you make sure all tests pass. This is the refactor stage. This may also be referred to as the clean stage. You will see in the assignment for this section that when you write your code, you will actually lead your commit messages with these names, either red, green, or clean or refactor, to indicate what you're actually doing and what's going on. So let's look at a very small example. This is using unit tests from Python, from the Python unit testing framework. Now, what we're going to do here is we have a class called test order information. This is my test class. It is my class that contains all of my tests. The syntax at the top there where it says unit test.testCase, which is passed into the class, that means that test order information inherits that in Python. And then we create one class method here, test_create order information. That self parameter just make sure that this is actually a class method. And this is the simplest thing we can do, right? We create a new version of the order information class. And then I have this thing which is the equivalent of the main function in C++, this if name equals main, and it says run unit test.main, which takes a look at these files and runs the unit test. So I have one test here. The test does something simple. It creates an instance of the order information class. This is our basic requirement. I have a class called order information. So that's what I did. When I run this, you'll see I run python test.py, and it gives me an error. The test create order information has failed, right? Ran one test, it's not defined, order information is not defined. So you'll see the fail at the bottom there. You'll see the error message. Both of these indicate that we have written a test that is now failing. If I were doing this in your assignment, I would now make a commit that said red, test blah, 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 failed. The simplest code to fix this problem is to create a class. In Python, we create a class this way, class order information. The init method is the constructor, and an empty constructor just takes the pass keyword. Okay, so it means it does nothing, and if I run that test again, it is green, right? So it passed. Now I would make a commit starting with the green keyword if I were doing your assignment. But you can see very clearly here, we have a requirement, create an order information class. We have a test that tests the instantiation of that class. We run that test, it fails. We write the simplest code possible to make that test pass, and then it passes. And we continue this cycle on and on and on and on and on. The key to test-driven development, to TDD, is that you do not write code unless there is a test for it. Right? Second key, test code is real code. Make sure you always keep your tests in a separate directory and always use version control. Many of you have done this, and you'll see this little screenshot I have on the slide from my own example. Keep your tests in what we would call a mirror directory. So if you have a bunch of source files and they're all in subdirectories and all these different kinds of things, your test directory should mirror the directory structure of your actual code. This gives you clean organization and lets you quickly navigate tests to either add new tests or evaluate tests, all those kind of things. Now the final two keys are something I want to go over that are very important. You can learn more about both of them in our architecture classes and our our testing classes. But when you're testing, you will run into problems, specifically with test-driven development. So say you're writing tests and there's another class that doesn't exist that you need, or you need to test some specific things, setting some specific patterns. So we have some tricks to help us avoid these situations and to give us some flexibility. The first one of these is called the strategy pattern. Now, this is in your book, and it is a widely used pattern of development. Okay? This is what we would call a design pattern. And basically what we do is we write an interface that is some generic interface. In your book, they use the example of a DB accessor. And then they create two other objects, a test accessor and a MySQL accessor. Both of them function in a different way. But what they let me do is something very special. If I were using C++, I could create a variable called DB accessor. I would normally create this as a pointer, DB accessor star. And then what would I give it? I could say DB accessor star D equals new test DB accessor, or equals new MySQL DB accessor. Why is this useful? Well, it lets me create one variable type, one base variable type, DB accessor, and then instantiate any number of a type of inherited classes on top of it. So, MySQL DB accessor and test DB accessor, these are all DB accessors. That means that I can instantiate them on a variable of that type and pass that around within my code and use it flawlessly. In this case, I've done this myself where we have a test DB, which is just a fake database, MySQL, Postgres, whatever you happen to have, but it gives us tons and tons of flexibility in how we pass objects around and how we connect them. All right, so this is really, really important. I would suggest you take a little bit of time, read your text carefully on this topic. You may not need it in the assignment, but you need to be aware of it and sort of familiar with it because it's a very, very popular design pattern. The other thing that we end up doing is using mock objects. So mock objects are also very important things. So you may want to test your code, but you don't want to have to instantiate all these wild objects and create this other object and make another class and set all the variables and things like that. So what you can do is actually create a mock object, and there are libraries for this. You see I provided the link for the unit test mock library for Python. Basically, it lets you create an object that mimics a class or an object, an instantiation of a class. They go over this in your text. I want you to be aware of it, okay? But it gives us a nice way to produce static behavior for testing patterns. So make sure you read this carefully in your book. Go back over the link to Python. So that in a nutshell is test-driven development. I do want to close with one anecdote. Just so you know, test-driven development is a very special thing. Workplaces that implement test-driven development and do it well typically do not look like what you would think of as your typical software engineering scenario. Normally, folks on test-driven development team, they don't have email addresses. They work in pairs doing pair programming, and they're off in their own room. And literally, their job is take the next requirement as a pair, implement it using test-driven development, repeat. That's all they do. They do it in pair programming, so they switch back and forth with alternating drivers of writing the code. But it is a very intense experience because you are so highly focused. That focus has advantages. You typically end up writing very good, very clean, very lean code. But it also has to come with accommodations, right? So these folks are intensely focused. They have monitors up detailing the results of their builds and tests. So most places that I've seen that use test-driven development really well, they run their teams like this, and every 1 to 2 hours, those teams get somewhere between 15 and 30 minutes to take a break, to get coffee, to go play ping pong, to do something like that so that they can clear their heads and get back to work at a highly focused level. So anyways, I hope you enjoy this section on test-driven development. I hope you learn a lot, and I'm looking forward to answering your questions and meeting with you all.